Hello, children. I am Mr. Dr. Professor Josh, and I'm here today to discuss the mole. So, what is a mole? Explain this. A mole is simply 6.02 times 10 to the 23rd particles of a substance. This is also known as Avogadro's number because he's a scientist that Benton came up with this. So that's your mole number. Okay, so you can use this. What we're going to do first is we're going to convert grams to moles. So you convert units of measure to moles. And, so let's do 50.4 grams of sodium. And so we want to get to moles. So we're going to, that's what we want to get to, and we're going to put the atomic mass of sodium on the bottom in grams, so we get the grams to cancel out, and that there. So now if you want to divide that, you're going to get 2.19 moles of sodium. So that's pretty simple, that's what you do there. So STP stands for standard temperature and pressure. So we're going to use this in the volume of 1 mole of gas at standard temperature pressure is 22.4 liters. So an example of this in a problem would be if you have, say, 6.7 moles of hydrogen, and you want to determine the volume occupied by this at standard temperature pressure. Well, you do that by doing the same conversion thing, 6.7 moles, take that and put 1 mole at the bottom, so that cancels out, and you want to multiply it by the volume of 1 mole of gas at standard temperature pressure, which is 22.4 liters. If you multiply that out, you're going to get 150.08 liters of hydrogen. So, right there, that's what you do. Alright. That's your formula there. So, for example, if you want to calculate the density of carbon dioxide gas at STP, the molar mass of that would be 44.01 grams. Just divide that by 22.4 liters, and that equals 1.96 grams over liters. So that's what you do there. See that? It's great. So, oopsie. So, last thing we're going to do here is we're going to do percent composition. So, the formula for that is to get the percent mass of an element. You're going to want to divide the mass of the element by the mass of the compound, and then you multiply all of that by 100. So that's going to give you what you want. See, that's the formula right there. You see it. That's very good. Alright. So for example, if you want to calculate the percent composition of a compound with, let's say, 9.03 grams of Mg and 3.48 grams of N. So to do that, you want to add both of these up. So you add the percentages of both of those up. You're going to get 12.51 grams in the compound. And so it doesn't matter which one of these two numbers you plug in to get the percent composition. For this, we'll just do it. 9.03 grams of Mg, and we're going to divide that by the whole number, or by the added sum of the compounds, or the elements. So that's divided by 12.51 grams, and that's going to, oh wait, we have to multiply it by 100. That's going to equal around 72, so that's 72% of Mg, because Mg is what we put in on the top. So 72% Mg, and so, you know, you want to get both numbers. So the mass of the percent composition of N would just be 28%, because, you know, that's 100%. 72, 28%. Very simple. Oh my gosh. So you see that right there. All right. So yeah, that's it here. I'll do it for our moles thing. Goodbye. Yes.